Hi, my name is Keith Tenzer. I'm a solution architect here at together.ai. Today, I'm incredibly excited to talk to you about how we build our Formula One race cars, which of course are the models we run, and show it off in a fantastic race. I cannot wait. But first, let us talk about the race car and handling, getting off the line, going into those corners quickly. That is our time to first token. At together.ai, we have an incredible research team of men and women that are in the pits pushing the envelope of what these models can do from a performance perspective. And there are several things that we do to get really low time to first token, such as quantizing down to FP4 without losing any accuracy. Kernel optimizations, not just the GPU kernel, but also the underpinning engine, and together optimizing that for a specific use case or model configuration. Pre-fill optimization, which is our KV cache, especially important for time to first token, is prefix caching. You can't waste any GPU cycles recomputing any information that you already have from prompts to documents or images. And then, of course, the network layer needs to be optimized. We do intelligent connection pooling so we don't create new connections, which waste a lot of latency. And in addition, having isolated, dedicated environments around our models ensure that we don't have any noisy neighbor scenarios. Next, speed. You got to have a big engine that's powerful and cranking out those tokens per second. And we do that through quantization, getting down to FP4, our kernel optimizations, the GPU itself, choosing the right GPU for the right job, and squeezing every ounce of compute out of that GPU. Speculative decoding, smaller models with smaller parameter sets, of course, can generate tokens faster. So the idea here is you take a smaller model to draft tokens, which the larger model then will correct. And if it can get 50 to 60% of those correct and right, then you see a boost in TPS. So there's a lot of research we do in that. And KV cache, as I mentioned earlier, as well as what is the most underrated of them all, in my opinion, is batching and batch sizing to get and squeeze the utilization out of these precious GPUs. And that is what we're about at together.ai. It's about price performance. And we want to win a race. And to win a race, you got to consistently perform. You got to consistently have low lap times. And that is our end-to-end latency. And the equation is dead simple. It's low time to first token plus high tokens per second is fast. Now, let's get on to the race. We've got some competitors. We've got the red car, the blue car, and the green car, all of which are running the same DeepSeek V3, which is a beefy open source model at 671 billion parameters. If you've ever used it, though, typically it's very slow. These are all running on together. They're all optimized, and you're going to see great performance here. We're using NVIDIA Blackwell 200s, all of which have the same KV cache configuration. The only differences between these competitors or cars is the speculator and quantization. The red car has none, it's FP8. The blue car has a spec, but is also FP8, and the green car has that killer combination of speculator and quantization. And we're going to see that in action. I've built a demonstration app that will take chat completions requests and turn it into a race. So each lap is a chat completions request. The request we're sending is to generate a 500-word essay, and each lap is a different essay that we ask to the model configurations to produce, and we measure its TTFT, TPS, and E to E while doing so. All right, the cars are lined up here and they are ready to go. Engines are running. The countdown is on and off they go. The green car with that FP4 speculator just launching off the line, lapping the red car, coming up on its third and final lap, lapping the blue car, and finishing the blue car with the speculator. However, no FP4. is now finishing its third, and the red car really struggling here to keep up with no speculator and just quantized to FP8. And there you have it, the end results. You can see here they all performed magnificently on the TTFT perspective. That is expected because they are all optimized on Together's platform using our KB cache and optimizations there, as well as the engine optimizations. It's really TPS. You can see it's almost 3x or more than 3x between the third and first place. It's an insane amount of optimization there that the speculator and FP4 give us. And then, of course, that low lap time. So I hope you've enjoyed this demonstration and insight into how we build our race car here at together.ai. If you want to go fast, you know who to talk to. We'd love to hear from you. Thank you for your time.